Picture this. If you trained an AI on literally all of human knowledge up to the year 1901, could it independently invent special relativity by 1905? Could a machine actually have an Einstein moment? Well, that right there is the ultimate test for true artificial general intelligence. We are definitely not talking about simple chatbots anymore, folks. We are talking about world-shifting, fundamental scientific discovery.
Welcome to The Explainer. Today, we are diving deep into the mind of Demis Hassabis, the CEO of Google DeepMind, to unpack his exact playbook. Look, from his early days as a chess prodigy to literally winning a Nobel Prize in chemistry for cracking the 50-year grand challenge of protein folding, the guy knows what he's talking about. We're going to extract his raw insights on the actual timeline to AGI, the major hurdles still in our way, and exactly how AI is going to completely rewrite the rules of science.
All right, here's our quick roadmap for today. We'll hit the missing pieces of AGI, agents and continual learning, the hidden power of small models, AI as the ultimate tool, and finally, how to actually build companies in the AGI era. Let's get into it.
Section 1. The missing pieces of AGI. What's actually standing between us and 2030?
So Hassabis predicts we could realistically see AGI by the year 2030. That is just around the corner. Now, he points out that the foundation is largely already there. The current paradigms we hear so much about, large-scale pre-training, reinforcement learning from human feedback, chain-of-thought reasoning, these are definitely not dead ends. He firmly believes these exact techniques are going to be a huge part of the final AGI architecture. So we are going to wake up in 2 years and realize we have to scrap everything and start over. But that doesn't mean the puzzle is finished.
Because there are still some massive algorithmic hurdles to jump. Current systems really struggle with continual learning, meaning gracefully integrating a new fact into their existing knowledge base without just instantly forgetting the old stuff. They also lack robust long-term reasoning. They often get stuck in these weird looping thought patterns, or they'll make an elementary mistake right next to some gold medal level math. And across the board, they severely lack consistent memory. Hassabis actually gives it a 50-50 chance that we are going to need one or two totally brand new big ideas to finally crack these specific problems.
Moving on to Section 2, Agents and Continual Learning, going from passive to active.
To really grasp why active agents are the future, we have to look at how we're handling AI memory right now. Honestly, we're basically cobbling it together with duct tape. When we want an AI to remember something, we just shove all of it into a massive context window. Think of the context window as the AI's version of human working memory. Except instead of you trying to hold maybe 7 phone numbers in your head, the AI can hold millions of words. But as Hassabis points out, this brute force method is highly inefficient. Even with a 10 million token context window, there is a staggering computational cost to digging through all that noise just to find the one single piece of relevant data it needs for a decision right now.
Plus, while text is cheap, reality is really expensive. When you try to process a dynamic, messy, physical environment, say an agent navigating your house using a live video feed, 1 million tokens isn't actually that much. In fact, 1 million tokens naively recording a video feed gets entirely eaten up in just 20 minutes. 20 minutes! So if you want an AI system to understand what's been happening in your life over a month or two, this whole context window approach completely breaks down. We desperately need true continual learning where the AI updates its underlying model on the fly, kind of like how our own human brains consolidate memories during REM sleep.
Section 3. The Power of Small Models, Distilling the Frontier.
While everyone is obsessing over massive supercomputers, there is this quiet revolution happening on the complete opposite end of the spectrum. Building the absolute smartest frontier models obviously requires astronomical amounts of compute. We know that. But once those giant models are fully trained, DeepMind uses a totally fascinating technique called distillation. Essentially, they can pack the vast majority of that massive frontier's power into tiny edge models. These distilled models are still 90 to 95% as capable. But here's the kicker. They are incredibly fast, hyper-efficient, and drastically cheaper to run. This is a total game changer, right? It means you can run a highly capable AI securely on local, everyday hardware, like your smartphone, your smart glasses, or even a robot in your house, without having to beam all your private audio and video feeds to some remote cloud server.
Okay, Section 4, AI as the ultimate tool, rewriting scientific discovery.
So what happens when we unleash these highly capable models on the physical world? Just look at AlphaFold. Over 3 million researchers globally use AlphaFold today. 3 million! That is practically every single biology researcher on Earth. Demis Hassabis even said that almost every single drug discovered from this point forward will have utilized AlphaFold somewhere in its pipeline. You see, DeepMind's goal was never just to build a cool chatbot. The goal was to use AI to solve what they call root node scientific problems.
Problems that are so fundamental, once you crack them, you literally unlock entirely new branches of human discovery. And if you want to spark the absolute next massive breakthrough, whether that's in material science, climate modeling, or medicine, Hassabis gives us this exact 3-step formula to find the needle in the haystack. Number 1, you have to identify a massive combinatorial search space. We're talking something so complex the traditional brute force algorithms completely fail, like the trillions of different ways a single protein can fold. Number 2, you must define a crystal clear objective function that the AI can hill climb toward. Something like minimizing the free energy in a molecule, or simply winning a game of Go. And number 3, you need vast amounts of really high-quality data, or better yet, a synthetic simulator that can generate endless data for you. When you get those 3 things aligned, pure magic happens. And the timeline for these incoming breakthroughs is honestly breathtaking. We started with AlphaFold cracking basic protein structures. Awesome. Now, AlphaFold 3 is out there modeling a broad spectrum of highly complex biomolecules. Right now, DeepMind is actively working on a self-contained simulation of a virtual cell nucleus, and Hassabis estimates we are only about 10 years away from a fully functional, highly accurate virtual simulation of an entire human cell. Just imagine a system where you can test experimental drugs completely virtually and get biological outputs that are practically identical to a real-world physical experiment. Incredible.
Which brings us to our final part, Section 5, Building in the AGI Era, the Founder's Guide. If you are a founder, an engineer, or literally anyone planning your career right now, you need to heed this massive warning from Hassabis. Please, whatever you do, do not just build a simple API wrapper around a foundation model and call it a day. The base models are inevitably going to update, and they will crush your wrapper business overnight. Instead, he says you need to combine where AI is going with hard physical disciplines. Think material science, quantum chemistry, biotech. Those highly interdisciplinary teams doing work in the real world of atoms are incredibly defensible. They are safe from getting swamped by whatever the next big AI update is.
But you've also got to consider this wild timeline paradox. Building a true deep tech company, like a new biotech platform or an advanced materials factory, takes roughly 10 years of nonstop hard work. But if Demis is right and AGI actually arrives around 2030, well, that's only 6 years from now. That means AGI is going to drop right smack in the middle of your company's building phase.
So how on earth do you survive a superintelligence arriving mid-journey? You have to operate under the assumption that AGI is going to be this overarching general brain. It is not going to have every single niche dataset crammed into its core weights. Actually, if you tried to stuff all global protein data into a general language model, it would cause massive regression in its standard abilities. So your job today is to build the specialized physical factories, build the highly niche real-world data pipelines, build the localized tools, because when that AGI brain finally arrives, it's going to look around for the absolute best specialized tools to plug into and operate. You want your company to be that exact tool.
Which leaves us with one very critical question. But before we get there, let's do a super quick, rapid-fire recap of the hard facts. AGI timelines point straight to 2030. The main bottlenecks right now are continual learning and consistent memory. The way we solve that relies on active agents, highly distilled edge models retaining 90 to 95% capability, and religiously following that 3-step alpha formula to solve root node problems. And the absolute bottom line for today? Stop building digital wrappers and start building the physical tools an AGI brain is going to need to plug into. Okay, now it's time for a hardcore debate. Do you think Hassabis' 2030 AGI prediction is a total stroke of genius or a massive overestimation? Tell me why down in the comments. And hey, if you leave a comment, check the description for a link to download our full AGI Founders Mind Map. Thanks for joining me on this explainer, and I'll catch you in the next one.